All right, we're almost done. So our last talk here is on the shifting architecture of cognition and brain function. In this, I'll give just a very quick overview of neurocognitive aging before presenting 3 studies that all triangulate around this idea that Gary Turner and I are working on, which is this default executive coupling hypothesis of aging. And we saw some snippets of it in some of these other talks. I'll try to put that into a broader framework and open up for a little discussion. All right, so going back to basically the founding of OHBM 25 years ago, Cheryl Grady conducted the very first functional imaging study examining activation in younger and older adults. And in this face-matching task, what we see is that younger adults had greater engagement of occipital cortex, and older adults had greater engagement of lateral prefrontal cortex. Now, when I was a postdoc with Cheryl Grady, we did a systematic search of the literature and examined every single study that had compared younger and older adult brains. And across these 80 studies, from perception, encoding, retrieval, and executive function, what we see is that this initial observation was in fact robust and reliable. So across these 80 studies that have done a whole brain comparison, there's reliable over-recruitment in lateral prefrontal cortex and greater occipital activation in younger adults. However, there's also another pattern of age-related brain change that's also quite interesting, and it's on the flip side. It's not related to activation per se, but of deactivation. So in this study conducted by Cindy Lustig, had a number of subjects perform a semantic classification task, and what you see is there's engagement in these typical task-positive regions, as well as suppression of the default network in these medial structures, medial prefrontal cortex, posterior cingulate. However, older adults, on the one hand, they showed, as I mentioned before, this greater lateral activation in prefrontal cortex, but also this failure to deactivate the default network. And this has since been a subject of a substantial number of inquiries. What I think is important to think about and consider is that the default network is not a task-negative system. It is an active neurocognitive system that is involved in multiple processes, including but not limited to self-related cognition, recollection, and semantic knowledge. So I'd like you to keep that in mind while we talk about how these networks are integrated with other systems. So I've been thinking about what is the nature of these age-related changes in lateral prefrontal cortex and the default network, and is there something common underlying these patterns of brain activity? And in fact, the first study that actually looked at the interactions between these systems was conducted by Symposium some years ago now, and this was during performance on an NBAC task. And what they showed is using the seed in posterior cingulate cortex, younger adults had greater within-network connectivity. So there's greater connectivity between the posterior cingulate and medial prefrontal cortex, shown on the bottom. However, older adults showed a distinctly different pattern. There was greater connectivity between the posterior cingulate and a number of regions, including those involved in executive control. So there's greater default executive coupling in these older adults during performance on the NBAC task. Now, when I first read this paper, it actually helped me make much more sense of my own data, which just being that there was a prior observation that showed it. So there's a lot of information packed into this slide. I'm going to walk through it fairly quickly. What we see here, this is a pattern of network interactivity in younger adults. This is actually a task by network interaction. And on the y-axis is the magnitude of connectivity with the frontoparietal control network. Now, I had our subjects performing 2 distinct tasks. One was an autobiographical planning task, and the other was a visuospatial planning task, the Tower of London. So when one engages in autobiographical planning, there's significant recruitment of the default network, and that system's activity is coupled with the executive control system, and the dorsal attention network is decoupled. However, when someone is performing a Tower of London planning task, the dorsal attention network is coupled with the frontoparietal control network, and the default network is decoupled. So again, as I said, there's a task by network interaction where the activity of the frontoparietal control system, it can flexibly couple with either the default network or the dorsal attention, depending upon the domain of the task. Now, when we have older adults perform these tasks, we see a slightly different pattern of connectivity. First off, one thing that's quite interesting is that when older adults are making autobiographical plans, we see appropriate engagement and coupling of the default network. That is, it's a very similar pattern as to the young. However, when older adults are performing the Tower of London task, we see that the dorsal attention network is coupled with the frontal parietal control system, and the default network is also coupled with the frontal parietal control system. So overall, what this suggests is that on the one hand, there's a reduced dynamic range of connectivity with advancing age, and also that the default network seems to have this stickiness to it, whereas in its tracking in its activity pattern with the frontal parietal control system. And it's not just that this network has a higher activation rate. It's actually oscillating along with the frontal parietal control network. It is upregulated during this task. So wanting to dig into this further, Gary Turner and I took advantage of the fact that the Tower of London is itself a parametrically modulated task. So what you can see is that there are a number of different moves by which to solve these puzzles, and it gets increasingly more difficult with the higher number of moves. So in this case, participants need to examine the goal configuration and the start configuration of these disks, and following a set of rules, moving one disk at a time with nothing on top, need to match the goal configuration. So this is the easiest way to explain the results, I think, is with a couple ROI analyses. In this, what we see is the pattern of activity in left dorsolateral prefrontal cortex. And in young adults, we see a parametric increase in activation in dorsolateral prefrontal cortex. However, in older adults, what we see is that the dorsolateral prefrontal cortex comes on and it stays on. It's rather resistant to this modulation effect. And there may be some neurovascular coupling issues that underlie this effect that certainly warrants more attention. However, looking at the flip side, a region of interest in medial prefrontal cortex, we see almost a mirror image of the pattern of activity in the young. We see a parametric suppression of activity in medial prefrontal cortex. However, in older adults, we don't see the same kind of suppression. And in fact, this is totally consistent with prior observations that there's a failure to deactivate the system. It hovers right around baseline. We then took as a seed region the dorsolateral prefrontal cortex and entered it into a multivariate functional connectivity analysis. And what we saw was that in younger adults, at higher levels of task difficulty, the left dorsolateral prefrontal cortex becomes more tightly coupled with the contralateral region. So left and right dorsolateral prefrontal cortex become more functionally connected with higher task demand. Older adults showed a qualitatively different pattern of functional connectivity. What we see here is that older adults' left dorsolateral prefrontal cortex becomes more functionally coupled with the default network at higher levels of task difficulty. And this is something that Gary Turner and I are calling the default executive coupling hypothesis of aging. And what we think is happening here is that with declining fluid resources, older adults are shifting their strategy and relying more upon their semantic knowledge of the world to try to solve these problems. And in the context of the Tower of London task, this is not an adaptive strategy. Now, I'm going pretty far beyond the data in that interpretation, but these are hypotheses that we're seeing across many behavioral paradigms and is emerging now in other neuroscience discoveries to lend support to that interpretation. One study that quickly followed our initial observation was that by Jenny Reich from Kristen Kennedy's lab, and they showed across the lifespan there are changes in the modulation of the default and executive systems, and the change in this modulation is coupled. So we see there's less, as mentioned before, there's less segregation between the default and the central executive network, and in fact, this is also correlated with worse fluid reasoning. So cognition is declining, and it is somehow tracking with default executive coupling. So that's not a very good thing. So this suggests that this is some aspect of age-related decline. However, I'm going to suggest also that it's not only about decline, that there could actually be some benefits that accrue by virtue of getting older. So moving on to the next study, we conducted a resting state functional connectivity study examining this pattern of default executive coupling. Just brief methodological note, we use multi-echo fMRI in our acquisition. Now, with multi-echo, you're able to directly determine T2 star change, and using a multi-echo ICA denoising approach can separate bold from non-bold signals. And Alex Martin, along with Peter Bannattini and other people, recently showed that multi-echo processing effectively removes the distance-dependent motion confounds from fMRI data. So we conducted this study in a large sample of over 100 young and 80 older adults. And first, what we want to examine is replicate the well-known observation of decline within the default network, and we effectively demonstrate it with ICA, and there's reductions in the functional connectivity of this system. But critically, what we hypothesize is that there be increases in connectivity between the default and lateral prefrontal cortex with advancing age. And we think we're going to see this in rest because by virtue of repeated patterns of activation over the lifespan, there should be less segregation between these systems and more integration. And again, we think this is because older adults change their cognitive strategy to a more semanticized approach. So here what we see, again, is this prediction where older adults have greater connectivity between the default network and dorsolateral prefrontal cortex at resting state. And further, we wanted to see if the previous task-based studies actually are replicating here. And so we associated the magnitude of this cross-network connectivity, and in fact, it is correlated with fluid intelligence. And this is all age-adjusted as well. So however much these two systems are connected and talking to each other, it certainly isn't helping fluid reasoning. And we know that there is a systematic pattern of decline with advancing age. I mean, this is the depressing aspects of aging that we all dread and fear. We get slower, or we're worse at working memory, episodic memory. Most laboratory-based measures, older adults perform worse, and they decline over time. However, that's not the only trajectory of age-related change. There's also an increase in semantic knowledge. Now, we measure this with vocabulary. However, it relates more broadly to just the accrual of life experiences that older adults have. And it's been suggested that there is this complementary capabilities hypothesis, that in the face of declining fluid resources, we actually leverage our stores of semantic knowledge to a greater degree in order to navigate the world. And let me just give you an example, though, because if you think of 18-year-olds and driving, right? Driving is an ability and a skill that we execute in the world. An 18-year-old is at their peak in terms of their fluid abilities, their hand-eye coordination, their visuospatial skills, but they are terrible drivers. Your best driver is somebody who's going to be in their 40s and their 50s because they have the experience of driving and they know what the rules of the road are and they know how to predict the behavior of the other vehicles. So there's a heightened level of skill there that involves not just fluid resources, but also relying upon semantic knowledge as well. And so there is about a sweet spot that occurs in the 40s and 50s where there's an optimization across these two trajectories. So we looked at semanticized cognition in the context of autobiographical memory. So here's a photo I took the other day while walking the streets of Rome. Many of you have probably seen this pillar and have seen other magnificent things in this city, and you can mentally travel back in time and remember those experiences. What's interesting is that older and younger adults talk about these experiences differently. Young adults tend to really focus on the spatiotemporal details of the event itself, whereas older adults, when they will tell a story, they'll bridge it more with semantic information and scaffolding that aren't specific in place and time to that event. So here's an example. I won't go through it in detail, but this in green, these are the episodic quality details of an autobiographic experience, and in yellow, semantic knowledge related to this memory. So this is a young adult's memory, and this is an older adult's memory. And we have a manualized approach to quantifying the content of these episodic and semantic features in autobiographical memory. And this was first introduced by Brian Levine in 2002, where, again, younger adults have more episodic internal memories, and older adults have a greater proportion of semantic external details. And we replicated this primary effect in our own larger sample. And then we actually did a correction for the amount of words that were spoken to get an assessment of the density of the episodic or the density of the semantic details in their autobiographical reminiscences. And then, of course, we want to see is this related to the shifting functional architecture of the brain? And in fact, we do see a significant association, but only in our older adults. So in the young, there's no association with semantic density of information. But in older adults, we do see a significant association between this default and executive coupling that's significant in the old, and there's a significant difference in the slope between the two. So what this suggests is that with this shifting architecture of cognition, this starts to lend support to the idea that as we shift more to semanticized knowledge, we start using our knowledge of the world, and this may underlie some of this shift between these two systems. So this is a theoretical piece that Gary Turner and I recently published in Perspectives on Psychological Science, and really the gist of it is that context matters. So older adults don't perform executive control tasks very well in the laboratory, whereas younger adults do. However, as we face problems as we get older in the world, we actually leverage our prior knowledge, and we can use our semantic knowledge of the world to navigate quite a number of things. And that there's an underlying shift in the functional neuroanatomy that might support this. So younger adults have this dynamic range, and they can couple or decouple executive control regions with the default network based upon the relevance of prior knowledge. However, older adults, again, have this stickier, less dynamic range, but greater connectivity between these systems is more persistent. And this may, in fact, give older adults access to prior knowledge during performance on goal-directed tasks. Now, we know that there is a broad background of network dedifferentiation, reduced modularity with advancing age. We see this across the brain. It's certainly not specific to the default and executive regions. However, we do see changes there, but we think there's something special about these particular patterns of connectivity that we see and how they relate to how older adults interact with the world and use their knowledge during performance of a task. And there have now been a couple studies that have since come out that lend some support to this. So on the one hand, older adults don't perform very well when they're learning new information and when they need to bind two arbitrary pieces of information. However, they perform significantly better if they're giving meaningful associations, such as the price of food. So in this study, older adults were asked to encode the value of particular grocery items that were on the one hand realistic and the other hand not. And you see a boost in memory performance when the associations are meaningful, and that memory boost is associated with connectivity between the default and control regions. Similarly, in another context, looking at aspects of healthy aging, we see that when older adults are performing a creativity divergent thinking task, that they have greater default executive coupling, and that this is significantly associated with their performance on this task and the generation of more creative ideas, presumably because it's based upon semantic knowledge structures and associations within that system. So to close, we see that there are changes in lateral prefrontal cortex and the default network in their activation that co-occur with advancing age, and that the default and executive regions are functionally coupled in healthy older adults. And these age-related changes in the functional architecture might actually predict this shift from fluid to crystallized cognition. So with that, I'd like to thank my collaborators, students, and our funding sources. Thank you very much for listening. And before I close out entirely, I would just like to give a plug. If you enjoy OHBM and you plan on coming to Montreal next year, and you also are a fan of network neuroscience, we're going to be hosting an OHBM pre-symposium on June 24th at the Montreal Neurologic Institute, and all of you are welcome, and you'll hear more about this in the coming months. So thank you very much.